Hello everyone, and welcome to the first video on this channel. This channel is mainly focused on solving and analyzing mathematical problems from the SAT, and so today we're just going to be going over 4 quick multiple choice questions. You can find these questions before or in the description if you wanted to practice it before yourself, before listening into my thought process and how I go about it. But without further ado, let's dive right into it. Question 1 reads, which of the following represents the statement, the sum of the squares of x and y is equal to the square root of the difference of x and y? Let me zoom in a little bit, just using GoodNote here. This is a very wordy problem, and we can see that we're supposed to transform the statement that they have provided us into a mathematical equation, looking at answer choices A, B, C, and D. While this is very wordy, my first thought is to try and break it into mathematical terms, such as a very clear one is equal to. This will basically be our equal sign in the middle of all of these equations. And from the left, which reads the sum, so sum is pretty important, of the squares of x and y. And on the right hand side, we have square root of the difference of x and y. Sum, as we know, is just simply addition. The squares of x and y, so if we took the squares, which is x squared and y squared, and we wanted to find the sum of it, we would just add it together. Next inside of the operator is the equal to and to the square root. So we have a big square root somewhere of the difference of x and y. To find difference between x and y, you subtract one from the other, and to find the square root of all of that, you put a big square root over it. We can see that this is exactly like answer choice A, and so we are going to select that. Well, this is a very wordy problem, and I'm sure there is a number, a specific time that you want to spend on average on each math question on the SAT. So what you could have done on this problem particularly to make it go by even faster without even solving for the right-hand side. What I mean by that is after you've read the sum of the squares of x and y, you already know this x squared plus y squared piece. Looking at all of the answer choices, none of them, or I shouldn't say none of them, all except A have something drastically different. So B, C, and D on the left-hand side has nothing close to x squared plus y squared. Only answer choice A has it, and so at this point of solving the problem, you can already know that A is going to be the correct answer. You can have confidence in that. And obviously, on the right-hand side, if they somehow were a bit tricky in writing their answer choices, and somehow it could have been square root of x minus y, because this still stays true to the statement provided above, it's just a different ordering. And so for us, luckily, the process of elimination still works because on the right-hand side, none of them says x squared plus y squared. So after just knowing the first half of the statement, you can already declare A as the correct answer, which will save you approximately half the time without figuring the right part of the equation, right of the equal sign. Moving on, question 2 reads, if A equals -2, then A plus A squared minus A cubed plus A to the 4th minus A to the 5th equals blank. We have some numbers. My first train of thought is to just simply plug in -2 for all places where A is shown in the equation. Take me a little bit of time to write it out. And I do believe these ones were non-calculator. 2 should be a simple enough multiplicative number that we can do some quick mental math on. And so to then actually figure out what all of these numbers turn out to be, we have negative 2 plus, we'll still write the parentheses just to differentiate them better. Negative 2 squared, which is negative 2 times negative 2 yields a positive 4. Negative times negative makes a positive. Negative 2 cubed, so if we know negative 2 squared is 4 from our previous simple math that we did, negative 2 to the third would just take negative 2 to the second and multiply it by negative 2 again. So we're just taking 4 times negative 2, which yields negative 8. If we continue this problem, negative 8 times negative 2 is 16. And negative 2 times 16 is negative 32. We can go ahead and add and subtract all of these together. The nice thing that we have here is wherever they have a subtract, there is also a minus, or a negative sign, my apologies. Minusing a negative sign is the same as adding the positive version of that integer. So we have negative 2 plus 4 plus 8 plus 16 plus 32. And that comes out to 58. I did some rearranging if you care to know what's exactly inside of my brain. 4 plus 16 is 20, 8 plus 32 is 40, 40 plus 20 is 60, so negative 2 plus 60 is same as 60 minus 2, which is 58, and so our answer choice is 58. This one's rather a pretty straightforward question. I'm not sure if there would be an easier way to go about it aside from just knowing mental math or having better mental math to just calculate all this inside of your head. If you are someone who needs to write it down step for step, you are not spending that much more time than someone who does mental math. As long as you can recognize the problem, recognize that it is a very straightforward, you plug and chug the negative 2 into all places where A is shown, and then you just solve for it. You spend maybe a couple of seconds, a handful of seconds, more than someone who has good mental math and can look at the problem and simply map it out. But a couple of seconds won't necessarily make or break for you. At least I hope it doesn't. Moving on to question 3, it reads, if 9 to the negative 2 equals 1/3 to blank. Okay, so there is a little bit of a mishap there. I should just write 1/3 to the x. What is the value of x? I think might have been an imaging error there. 9 to the negative 2 equals 1/3 to the x, and what is x? Well, this doesn't look, or the left and right have different forms for their base. There's a base, we'll do a base that's taken to a power, and we wanted to write it in a form such as the base is the same so that the powers can be comparative. In the left-hand side, if you know what any number taken to a negative number means, I'll just do a quick demo, such as 2 to the negative 1. When any number, whole number, positive whole number is taken to a negative exponent, you simply take the reciprocal of the base and then take it to the positive version of the power. So the reciprocal of 2 is 1/2, and you take it to the positive power, which is just 1. So that negative 1 became a 1. And so therefore you get 1/2. To take 9 to the negative second, again, we'll take the reciprocal of the base. If the base is 9, the reciprocal is 1/9. And we take it to the positive power. So instead of negative 2, now it's just a 2. 1/9 to the 2 is 1/9 times 1/9, which equals 1/81st. Oops. Let me rewrite that a little bit better. So if we know the left-hand side is 1/81st to 1/3 to the x, we can also recognize that there is a pattern here. If we were to take 1/3 to an x power, and we see the answer choices 1, 2, 4, 6 are all whole numbers, so 1/3 to the first is just 1/3. But if you take 1/3 to the second, this will become 1/9. If you take it to the third, oops, got ahead of myself there, which means 1/3 times itself 3 times, you will get 1/27th. And then just one more time to the fourth, you will get 1/81st. So in our instance, 1/81st can literally be written as this. It's a long form, but if it helps you understand / visualize what's going on, let me write it for you, to the x. And so something taken to the power is however many times the base has to multiply it by itself. And in this instance, it's 4. So 1/81st, or yeah, 1/81 equals 1/3 to the fourth. So our answer is simply going to be 4. Again, this can be a more straightforward question, just like question number 2. As long as you can recognize what's going on, why the right-hand side is already in fraction form and the left-hand side has a base to a negative power, which will then eventually be rewritten as a fraction. If you're good at mental math, you may perhaps already figure 9 to the negative second will just be 1/81st, and 1/81st on the left and 1/3 to the right raised to an exponent. You got to find the relation between 3 and 81, because as some of you may already know, 3 to the fourth is 81. So 1/3, the reciprocal of 3 to the fourth, will equal the reciprocal of 81, which is 1/81. A little bit of mental math can save you just a tad bit of seconds, maybe here a handful of seconds, but if you were just being straightforward, recognizing what kind of problem it is, and get to solving immediately, you're going to use just a smidget of time to solve it anyways. Let's move on to the last question of this multiple choice practice. We have 1/8 plus 1/10 equals A over B. And the question reads, in the equation above, if A and B are positive integers and A over B is in its simplest reduced form, sounds quite important, what is the value of A? So there are two different ways to go about this, I feel like. If you want the straightforward approach, let me show you right now. 1/8 plus 1/10, and you're basically wondering what the heck it is. It's A and B on the right-hand side are both unknowns. We'll just write it as the easiest way is to find a common denominator. The quickest way to find a common denominator is to just simply multiply the two denominators by each other. So if I say the common denominator of 1/8, which is the denominator of 8, and 1/10, which has a denominator of 10. Oops. Wonder where all that went. Oh, weird. It went away for a little bit. And it's a little bit screwy, but just make do with it. 8 is the denominator, and plus 1/10, which 10 is the denominator. 8 times 10 is 80. So something over 80 plus something over 80 will yield something over 80. What is 1/8 scaled to something over 80? If you multiply the bottom by 10, you have to multiply the top by 10. This way, if you multiply a fraction or anything by 1, which is 10 over 10, anything divided itself as 1, you're not changing the value of it. You're just simply changing the way it's written. And we'll do the same thing for 1/10. 1/10 on the bottom, you have to multiply it by 8 in order to get 80 as a denominator. So we're going to multiply it by 8 on top, which yields 8 over 80. Again, you're multiplying 8 over 8, which does equate to 1, because 8 divided 8 equals 1. So therefore, you're not changing the value, you're just changing how it's written. 10 over 80 plus 8 over 80 is simple addition. You can just add across because the denominators are the same. So 10 plus 8 equals 18. Now, we do have to go back and realize that it asks for simplest reduced form, which begs the question, 18 over 80, can it be reduced? And one of the simplest reductions you can do, if you don't want to give too much thought to it, is they're both even, just divide both of them by 2 or reduce it by 2. So you can do 18 over 80 divide 2, which 18 divide 2 is 9 and 80 divide 2 is 40. Are there any other numbers that you can reduce this by? No. The numbers that make up 9 are 1 times 9 and 3 times 3, and you can't divide 40 by 3 or 9. So this is the simplest reduced form. And if this is equal to a over b, and it's asking what is value a, your a is therefore 9. This is the nice and simple, straightforward way to do it. But again, there is a mental math way to do it, and most people will be able to do this. Taking a look at 1 plus 8, or 1 over 8 plus 1 over 10, 1/8 plus 1/10, and we know eventually we want a over b to be in the simplest reduced form. Instead of going through just simply adding the number and then reducing it, we can find what's called the greatest, or no, not the greatest, it is the least common denominator, which means between 8 and 10, which of the smallest number, which is why it's called least, what is the smallest number that they have in common? 8 times 5 equals 40, and 10 times 4 equals 40. This is a number, a multiplicative number, a product that they share. So therefore, we can change the denominator to 40. So if originally we had 1/8 and we multiply it by 5 over 5, again, we're multiplying it by 1. This does not change the value of it, just simply how it's written. And we add 1/10. Now we want to write it as something over 40. 1/10, we know 10 times 4 equals 40, so we multiply this by 4 over 4, which is 1. 4 over 40 will equal 9 over 40. As you can see, we've already gotten to this step, 9 over 40, just by knowing or thinking, coming to the conclusion that 40 is the most common product between 8 and 10. While 80 is a step above it, 40 is the lowest number that we can think of. And therefore, it is already in the simplest form. Now, it could or could not have been. Perhaps it would have been in a form where you needed to divide by 2, divide by 3, whatever the number is. But this does get us a step closer just by realizing what the least common denominator is. And so again, if you know it's the sum of 1/8 plus 1/10 equals 9 over 40, and it's already in simplest reduced form, therefore the 9, which is in place of the A is what it's asking for, so you can go ahead and select answer choice B. That is all for the multiple choice practice we're going over today. If you have any comments, if you have any questions, feel free to leave them in the comments down below. Again, you can find these practice questions from the link in the description down below. If you would like to read their explanation, please go ahead and do that. I do know that all of the answer choices I've gone through today are correct. I've verified it myself, and I do believe my explanation versus theirs are pretty similar, except for I just provide sometimes more ways of thinking about it, ways to potentially, because some of them it really isn't a quicker way, but some of them that do, you can kind of find little shortcuts, and each little shortcut will net you a little bit more time on the rest of your questionnaire. Any comments, any suggestions, please leave them in a comment down below, and I'll see you next time. Thank you so much for watching.